In this video, you'll learn how to find the area of a regular polygon using special right triangles. So it's important to do a little vocabulary review. Remember the word that regular in this context means all sides are congruent and all angles are congruent. This one's asking us to find the area of an equilateral triangle with a radius length of 4 centimeters. And then it asked us, if necessary, to write our answer in simplified radical form. And simplified radical form, I want to remind you, you're going to end up with either pretty much a whole number with no radical, or you're going to end up with something that contains a radical in it somewhere. Okay. One more thing, area of a regular polygon is 1/2 times apothem times perimeter. Remember, A is apothem and P is perimeter. What you see in this diagram, here's the center of your triangle. This 4 centimeters is referring to the radius, and we need to have the apothem, which is this length here. We'll call this is our distance of A, our apothem. So what we're going to do in order to find this, we are going to circumscribe a circle around this triangle. And in the words of Beyonce, that would be put a ring on it. So we are going to put a ring on it. And I'm going to draw a radius from the center to all of the vertices, every vertex. So we're going to do this. It kind of looks like that thing from Harry Potter a little bit. But here's why we're doing that. So think about this. There are 360 degrees in a circle. And in this circle, we have divided this into 1, 2, 3 sections, or 3 triangles. 360 divided by 3 is 120 degrees. So that tells me that this angle here, each of those interior angles is 120 degrees. Okay, so I know each of these is going to be 120, but I want to focus on this little triangle right here. That's where I'm going to draw my entire attention, is that triangle, and I'm going to redraw it so it's easier to label. So I know the apothem is creating a right angle with the sides, so we have a right triangle here. I know the radius is this distance here, 4 centimeters. And I'm looking for the apothem. Now here's the other piece of information I knew. When we put a ring on it and we did all this stuff with the green, I know the entire angle is 120, but what I've done is I've drawn in an apothem to cut that in half. So this angle here, the whole thing is 120, but half of it, this little half of it here is just going to be 60. So magically, I have a 30, 60, 90 triangle, and we know a way to solve those as a kind of like a shortcut. Okay, so I know this is my hypotenuse. The hypotenuse is always across from the right angle. And to go from the hypotenuse to our short leg, we are going to divide by 2. So 4 divided by 2 is going to be 2. So my apothem equals 2. And then this side, right here, the long leg, we take our short leg times the square root of 3. So our long leg here is 2 root 3. Now, this is important. This 2 root 3 is only part of this. So 2 root 3 is only half of it. The entire side length would be, so let's write this down here. The side length is 2 root 3 times 2. Which is just the same thing as 4 square roots of 3. Okay, we're only going to multiply those outside. 2 times 2 is 4. We leave the radical. All right, so now we are to the point where we can do area is 1/2 times apothem times perimeter. We have enough information that we can fill this in. So 1/2 times the apothem, we determine the apothem is 2. Okay, and the perimeter, we don't know the perimeter right now, but we know that since this is a regular polygon, this triangle is an equilateral triangle, all the sides are the same. There are 3 sides in the triangle, and each side is 4 square roots of 3 centimeters long. So here's how we filled our formula in. Now, maybe you're sitting at home thinking, okay, but how do I write this in simplest radical form? Well, what we're going to do is we are going to multiply all of the numbers that do not contain a radical. So 1/2 times 2 times 3 times 4. Okay, so we're going to do that 1/2 times 2, oops, times 3 times 4. So 12. I'm going to change my pen back here. So 1/2 times 2 times 3 times 4 is 12. And then we just put our square root of 3 on at the end. 12 square roots of 3. And 12 square roots of 3 centimeters squared would be the way we label that. So that's how you find area of a regular polygon using a special right triangle. The first thing we did was we circumscribed a circle. We put a ring on it. Then we divided it up into sections to see how big would each interior angle be. We determined it would be 360 divided by 3, which is 120. From there, we made a smaller triangle, and we figured out that's a special right triangle, and that helped us solve for the apothem and for the side length, which helped us determine the perimeter. I'm going to show you one more. Okay. So to find the area of a regular hexagon with an apothem length of 6 meters, if necessary, write your answer in simplified radical form. So the first thing I'm going to do is I'm going to put a ring on it. Okay, and then I'm going to figure out how many triangles do I have from the center. I've got 1, 2, 3, 4, 5, 6 triangles. So I have 360 divided by 6, which will be 60 degrees. So I know that this would be 60 degrees right here. And I'm going to erase all of these extra markings because it's just a lot to try to take in. Okay, but I know that each of those larger angles is 60. So if I have this triangle and I know the whole angle is 60, then I know that half of it will be 30. So I'm going to draw that triangle larger off to the side. My apothem is this length right here, which is 6, and that's perpendicular to the side. So I know this is a right triangle. And as I said before, we said this is 60 degrees for the whole angle, but I'm dividing it in half. Okay, when you divide it in half, for 30, and so we have a 30, 60, 90 triangle. And now this is where it's kind of tricky because we are trying to get from our long leg to our short leg. This is what we need. We need to figure out this distance. And so I want you to think about when you have a special right triangle, 30, 60, 90 triangle, you usually you go from the short leg to the long leg. You're going to take it times the square root of 3. But to go backwards, to go the other way, we're going to go from long to short. We would have to divide by the square root of 3. And this is a pain in the neck, but it has to be done. So here we go. We are going 6 divided by the square root of 3. And this isn't going to fly. We need to make sure we have no radicals in the denominator. And so we have to do what's called rationalizing the denominator. In my class, we say this is doing the thing. So we're going to do the thing. We're going to take it times root 3 over root 3. So at the top, we'd have 6 square roots of 3 over the square root of 9. Okay, so 6 root 3 over square root of 9 is 3. And I can take this one more step. 6 divided by 3 is 2, and we'll leave radical 3. So the side length x is actually 2 radical 3. Now remember, we're trying to work towards this formula, 1/2 times apothem times the perimeter. And I don't quite have enough for the perimeter yet. I know this side is 2 root 3. So the whole thing would be 4 root 3. Or you could think of it as 2 root 3 times 2. That's our side length. Okay, so let's fill this in. 1/2 times the apothem, which is 6, times the perimeter, which we know there are 6 sides total, right? 1, 2, 3, 4, 5, 6 sides, and each of them are congruent. So 6 sides, and I know that each side is 4 square roots of 3, what unit are we looking at? Meters. Okay. So this is my entire formula, and I'm only going to type in the things that don't have a radical around them. So I'm going to go 0.5 times 6 times 6 times 4. So this is going to leave us with 72. And then I cannot forget about that square root of 3 on the end. 72 square roots of 3, and then we'll label it with meters squared. And that's how you find area of a regular polygon using special right triangles.